This is the Honors Math 2 Unit 3 review. We'll start with number 1, where we need to state the postulator theorem you'd use to prove each pair of triangles congruent. So our options are, we have our side, 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 angle, side, angle, angle, side, HL, or not enough information or not congruent. Number 1 looks like it's going to be a side, angle, side problem. We can even throw vertical angles there, but we have to be careful because these corresponding sides are not marked congruent. It's just telling us one's in the same triangle, which makes them isosceles triangles, but not all isosceles triangles are congruent. So this one's going to be not congruent. Number 2, we get reflexive property for the shared side. The parallel lines lead to alternate interior angles here and here. So this one comes out to be an angle, side congruence. Number 3, with reflexive property, comes out to be angle, side, angle. Our two angles have the side in between them, whereas this one over here, it was two angles and the side was not included between the two. Number 4, we're going to mark vertical angles and go angle, side, angle. Number 5, we have reflexive property, and that'll be side, side, side. Number 6, by reflexive property, is going to give us side, side, side. Number 7, we have right angles. We have the sides opposite the right angles and the sides next to the right angles. This is not angle, side, side, which does not work. This is not side, side, angle, which does not work. It's the special case when you have right triangles, so it will be HL. The hypotenuse and the leg in a right triangle. Number 8 is not enough information or not congruent. We just only have 2 parts. You always need 3 parts in order to show congruence. Number 9, we have this angle here, which is actually in both of these triangles. So when I separate these two triangles, I see with the right angle, the congruent angle, and the side between them, it's going to be an angle, side, angle congruence. For number 10, we need to find the values of x and y. It's an isosceles triangle, so we know these two angles are congruent, so y equals 65. I have 65 and 65, that gives me 130, so that leaves me 50 degrees for x. Number 11, another isosceles triangle, so I know both of these base angles are 59. We add those together and we get 118. If that's 118, then x is going to be 62 degrees. That's what's left over. We could then come over here and go with vertical angles, which is going to put a 62 here. But really, these two triangles are similar. This is also going to be 59 and 59 with the 62 here. Not because they're congruent, but just because the angles are going to work out to be the same. But the vertical angle gives me here 62. That leaves me with 118 for both of the other angles that are also congruent. Number 12, we have these two angles here are both 25. Together, that gives us a total of 50. And since it's an isosceles triangle and you have 50 right here, these are each 65, which means x is 65. But we also get, when you take a isosceles triangle and bisect the angle, it turns out to be perpendicular to the side, so y is going to be 90. For number 13, we have an equilateral triangle, so all the angles are 60. With that, we know that 60 and angle y have to add to 90, so y is 30. And then if y is 30 and we have a 90 degree angle here, angle x would be what's left in that triangle, which makes x 60 degrees. For number 14, we need to name all pairs of corresponding congruent parts. We should have 6 pairs. First, we'll start with angles. Angle C is congruent to angle M. Angle G is congruent to angle P. And angle I is congruent to angle R. We can then go by sides. I'll go first 2 letters. CG is congruent to MP. We'll go GI, second and third letters, is congruent to PR. And last, the first and third letter is CI is congruent to MR. So anytime we have 2 congruent triangles, we get these 6 sets that work. For number 15, we have overlapping triangles, and we need to see what is congruent. Well, I know I have reflexive angles here at L. Those are in both. We have LMKM. We also have LN and LJ. So it might be easier if I separate these two triangles. So I have LKN, and the other one we have LMJ. So things we know, the ones that L are congruent. We know LK, LM, as well as LJ and LN. This comes out to be a side angle side congruence. For number 16, we have reflexive property again at BC. We then have angle ABC and DCB are congruent. We also have these smaller ones here are congruent. So when I draw these triangles separately, we get two sets of congruent angles and the sides between them, so that'll be angle, side, angle. For number 17, angle E and D are congruent, and then DCF and EFC are congruent. Add in that the reflexive property, and I have two sets of angles and a side. Be careful, because if we have two sets of angles and a side, it's one of those two. We have to pay attention to what the order we have. If I drew one of the triangles off to the side here, by what I have, it's an angle, angle, side, because the side is not between the two angles. For 18, we're going to go reflexive property here. We already have some right angles, and then HI and JG. Another one that can be tough to identify, so let's just draw one of the triangles. Let's take HIJ out of it. I have a side, a right angle, and a side there. This is not side angle side. This is not angle side side. Since it's a right triangle, it's going to be HL. So for number 19, we're going to write our proof. So we have BD is the perpendicular bisector of AC, and that's our given. Okay, what we get from that is perpendicular tells us that angle ADB and angle CDB are right angles. And that's our definition of perpendicular lines. Now, if we have perpendicular lines and we have right angles, we also know right angles are congruent. And that's our goal here, get the two angles congruent. So that's ADB is congruent to CDB. And that's because right angles are congruent. So let's put that there. Now the other part of that is bisector. So if it's a bisector, we know that AD is congruent to CD by the definition of a bisector. You could also really say definition of midpoint, because it's the same idea here. So that's going to be those two parts. So now we have two parts congruent. We have a set of angles, a set of sides. The third part we pull from the diagram, and that's DB is congruent to DB. And that is our reflexive property. So by that, we now see our two triangles are congruent by side angle side. And we'd say that triangle BAD is congruent to triangle BCD. Now for number 20, we're going to start with BD is perpendicular to AB, and BD is perpendicular to DE. And we'll throw in BC is congruent to DC as our other given. Now, these right here, these perpendicular, kind of lead to what we just had in that last problem. So now we're going to say, since we have perpendicular, angle B and angle D are right angles. And that's our definition of perpendicular. Then once we have the right angles, we can say that the angles are congruent, because right angles are congruent. Next, we can go here and we need to find our vertical angles. So that'll be angle ACB is congruent to angle ECD, because vertical angles are congruent. So in our diagram, we now have two congruent triangles. Our two congruent triangles is triangle ACB is congruent to triangle ECD, and the reason being angle, side, angle. What we need to get to is that angle A is congruent to angle E, and we know that because corresponding parts of congruent triangles are congruent. And that is our reason that shows us that A is congruent to E. Get the congruent triangles, then the corresponding parts are also congruent. For 21, we have angle WVZ and angle VWX are right angles. And we also have WZ is congruent to VX, both given. So off of that, let's go and say that WVZ is congruent to angle VWX because right angles are congruent. We have also side WZ and VX, so we'll mark those here. Be these crossing sides. So let's just draw these two triangles separately. Maybe that'll help us. So I have VWX and VWZ. So I know these two sides are congruent. I got some right angles there. What else we have is the reflexive. We have VW is congruent to VW. So looking at that, I have right angles, I have a hypotenuse, I have legs, so this could be HL. We want to be careful here though. We said right angles are congruent. What we could also add to this is we're going to say that WVZ and triangle VWX are right triangles. And we want to say that because in HL we want to make sure we have right triangles. It's not so much important that the right angles are congruent, it's that we have right triangles. And we'll add to that the definition of right triangles. So we're trying to prove that WVX is congruent. WVX is congruent to VWZ, which we have. So now we can say the two triangles congruent, WVZ congruent to triangle VWX by HL. For number 22, I start with angle 1 is congruent to angle 2, and WX is congruent to ZY, both given. And what I'm going to work on first is I'm going to try to figure out that these outside two triangles are congruent. So I know this part and this part here, and then these angles are congruent. I got to get the rest of it. What happens here though, if we look at triangle PWZ, is if these angles are the same, we know that PW is congruent to PZ because of the isosceles triangle. Because if the base angles are congruent, we know the sides are congruent. So that works there. Now, when we come back and we look at our two triangles, kind of draw them by themselves here, I have congruence here, I have congruence in the side, and I have congruence in the angles. So that tells me that triangle PWX is congruent to triangle PZY, and that's going to be by side angle side. Why that helps us when we're trying to get now to angles 3 and 4, because we have two congruent triangles, we know now that these two sides, which in this case is PX and PY, are also congruent. So PX is congruent to PY because corresponding parts of congruent triangles are congruent. Because now, if I look at the inside triangle of PXY, I have that side congruent to itself. I'm looking to find 3 and 4. I can now say angle 3 is congruent to angle 4 because it's an isosceles triangle. So we kind of got around the proving the angles in different triangles, but used the corresponding parts to get to the isosceles triangle and prove that the angles are congruent. For number 23, we're proving that we have two triangles congruent, but they give us a hint kind of along the way that we're going to prove QPR congruent to SRP, then get to STR to QTP, which is really our goal. So I've kind of written out the plan for this proof I'm going to have. I'm going to start with my givens. I'm going to try to get these two triangles congruent. Once I get to those, I'm then going to work to get these two triangles congruent, which is my end goal. So working with what I have. Off of the diagram, I had that Q and S were congruent. I also had those angles there. If I go up to this one, I also had PR on that triangle. Let's start working with this triangle. So things I notice first. I have right angles. So if I have right angles, I can also say that angle PSR is congruent to angle PQR because right angles are congruent. I know they're right angles. I know I have them labeled already, but we have to name the fact they are congruent. What we can also then do is go with reflexive property and say that PR is congruent to itself. There. So now when I look at my two triangles, I have they are congruent by angle, angle, side. So that part's checked off. Now here's my goal. So I did this to get angle, angle, side to really get some corresponding parts of congruent triangles are congruent. So what parts from these two triangles show up here? And what happens is PQ and RS, the top and bottom sides, are also in those two triangles. So I'm going to say PQ is congruent to RS because corresponding parts of congruent triangles are congruent. Added to the fact I already have angles at P and R, I only need one more piece. And the ones I'm going to use are in fact the vertical angles, which is angle PTQ, and RTS. Because vertical angles are congruent. Now with that, I can now look at my two triangles and say they are in fact congruent by angle, angle, side. For number 24, we need to find the congruence transformation that maps ABC to DEF. Now there's one that I'm going to go with is I'm going to rotate this triangle 90 degrees counterclockwise. So this point now goes over 1, up 2. When I rotate it 90 degrees counterclockwise, it's going to rotate over to quadrant 2 and then go up 1 and over 2. So this we're going to write as C prime. B, which was left 2 up 3, is now going to go down 2, left 3. And then A, which was back 4 up 1, is going to go down 4, left 1. So this now gives me that rotation. Now from here I can see with the reflection it does match over to the image. So what we could have done there is we could have rotate 90 degrees counterclockwise, then reflect across the y-axis. For number 25, what I can first do is I'm trying to match ABC to DEF. So why don't I move ABC over 2 to the right? If I moved it over, I now have it lining up to match, but the problem is when I reflect here, is it still going to go to the same point? It looks like F is actually 3 points or 2 units away when this is 3. These two match, but then again we have 3 and 2, so that's probably not a good plan to go with. Let's try to rotate 180. So let's take this and rotate it 180 degrees around. So I went down 3, left 2, so now I'm going to go up 3, right 2 to give me A prime. When this rotates 180, it's just going to be on the vertical axis. So that will just go up 4. And then C, which is down to right 2, will go to here. So looking now, A, we want to get to D, will now go 2 to the right. So let's go a rotation of 180 degrees, clockwise or counterclockwise, doesn't matter, same thing, and then translate 2 units right. 7a, we need to translate a triangle 4 units down, 5 to the right. So that gives me C. There's A. And then B would be here. So that's A prime, B prime, C prime. Draw in that triangle. Then it asks us to then reflect this triangle over the line y equals -1. Y equals -1 is the vertical line. Try it again. Y equals -1 is the horizontal line through -1. So if I reflected that, B, which is 1 above, now goes 1 below, and that's B double prime. A, which is 2 below that, now goes 2 above the line. And C, which is 2 below, goes 2 above, and we end up with this triangle. Now, for 28A, we're going to rotate the triangle 270 degrees counterclockwise. 270 degrees counterclockwise is the same as 90 degrees clockwise. So if I look, 90 degrees clockwise would take me over here. So it's going to be probably on this line, this x-axis on the negative side. So first, Q, when it rotates 90 degrees clockwise, is going to end up here at Q prime. Then P, which went down 4, left 1, is going to go left 4, up 1, and be P prime. R, P and R, which are now going to be vertical line here, it's going to be 4 units away from P, so I'm going to go down 4 units to R, and I have my rotation. Follow that, I'm now going to reflect over the y-axis. Here's the y-axis. When I reflect over, I get Q double prime, P double prime, and R double prime to give me my image